Now hope you can see my screen. So now let's start it. Uh-huh. Yes, so I shared. So our electronic instrumentation, what we'll read in our subject. So first thing I will see as a measurement system. So what is the meaning of measurement system? Now you think about there are several physical parameters, and we define some parameters like temperature, pressure, all those things. And the most scientific way of treating those is to know about the parameters, and quantitatively you want to know that the amount. That is the main difference between the subject, between the philosophy and the science. So whenever you are reading science, you have to quantify the parameters. That is the main difference. But in philosophy you can vaguely say something that good, bad, more, less, high, low, like this. But in science you have to quantify it, and so for quantification you need a unit, so we frame our unit. And then if there is a physical parameter, you want to know that how much is the physical parameter. For example, if you say the temperature, your body temperature, I will next ask that what is the value. Then you have to choose one unit and you have to say some number, numerical values. Okay, 97.5, 100.1, something. So to know that, suppose you have a body temperature and you want to measure it, you need some instrument to measure it. So with feeling you can say high, low or something, but it is not precise, and neither all the parameters you can feel. So you need some measurement, you need some instrument to measure it, which we call the measurement. And this is a single quantity, single parameters you can measure. Now you consider a system which in which you may need to measure many parameters, right? For example, you see that suppose you have an automobile, simple, a scooty you have. So what you need to measure? You need to measure that how much oil you have in your petrol tank. You need to measure how much speed you are moving. You need to measure the engine temperature, so on and so forth. So all those measurements, individual instrument you will use to measure individual parameters. And as a complete, you will see in a system there are so many measurements. So all the measurement consist of and will create a system which we call the measurement system. One thing I should emphasize to you, that measurement system does not mean that measurement system does not mean that you are measuring only with hardware, because nowadays there is no measurement system exist with only hardware, right? So maybe only the mercury thermometer you can say that it is only hardware, only mercury is there, it rises and then you get many you get the readings. Okay, so you see that the measurement system is consist of many measurements, and individual measurements and collection of all measurement consist of hardware and software. Now you come where the hardware is coming. For example, if you see an instrument, you need to have something which will sense it, sense the parameter, physical parameters, and change something into some voltage or some current, and then you measure it. Then once you measure, you enter into the software part. There you have to process the measurement. How you will process the measurement? Maybe you need to wipe out the or decrease the noise. Maybe you need to increase the sensitivity. Maybe you need to linearize it. Maybe you need to memorize it on your instrument, and maybe you need to interface it with other instrument or the main system. So whenever I say a measurement system, it means of many equipments together, and all the equipments have hardware as well as software, and overall all the equipments are interfaced with the software, with the main processor or the main system, so that you can get a complete picture about the different parameters which you need to know in your measurement system. Okay, so here I wrote a few things are written. So this measurement system includes all the components in chain of hardware and software that leads from the measured variable to processed data. So there are two things. First thing, it start with the measured variables, that means measure end, and then ultimately you get some output which is a processed data. So that can happen for a single instrument, that can happen for a system of instrument, that can happen for many instruments altogether. So the measurement system, when you said, it includes all the component chain of hardware and software that leads, so that takes the measurand from the measurement medium or the variables, some variables it takes, it sends, it process and give you some output. So that is the complete thing in measurement system. So people generally mislead whenever you say that there is some measurement system. People generally think that it is only hardware. So, but it is not only hardware. It is consist of hardware and software both. Although throughout this uh, course we will emphasize on the hardware part, and software part, you know, very little I will emphasize, because you have many other course to read it. For example, signal processing course, digital signal processing course, okay, signal system course, all those course you have, so where you can read those uh, software parts and how to process it. Here mainly we will concentrate on the hardware sensing. But remember, the measurement does not mean only hardware, it means hardware plus software, that means processing the data. So that's what I was telling, that in a modern automobile, take a system like automobile. So there are kind of 40-50 sensors which are measuring different parameters. It is not necessarily all the measurement will be displayed to your panel where you are driving. Not all the measurements are displayed. Other measurements are used to control some parameters like fuel injection. You will not see how much fuel injection is happening. Okay. Oil pressure, you will not see, because you don't need it. But to get the internal work done, you have many sensors, around 40-50 sensors in present automobile, and they are implemented for various functions necessity to operate the car. Few of them are shown in your panel board, and most of them are not shown the parameters, but their data are used, and accordingly decision is taken, and some other works or other processes to be followed, or it is initiated. So now if you go to the aircraft, this number of sensors there is, it could be like thousands of sensors. Many are displayed and many are not displayed. They are taken as internal parameters and used to control the various physical properties of the aircraft. Now, knowledge of the instrument available for various measurements means how they operate and how they interface with the other parts of system is very essential for every engineer. So suppose you want to build an automobile. So first you build all the hardwares and all, then come into sensing part. So you need to devise that what are the sensors that are required and what are the functionalities. Among them, how many sensors will be displayed, how many sensors data will not be displayed, and where the data is being used. Those things you need to meticulously design, and it is very essential for every engineer. Now in modern engineering system, it relies heavily on the sensors, because sensors monitors, and the monitor value is used to control the optimum operation. So without sensors, you cannot imagine about the modern engineering system. And in this class, we'll read all about the sensors, how the sensors are built, how they sense, everything. So, and what is the consequence after you sense some value. Now, if you come gradually that there are, what now you may ask, okay, so now I understood what is the instrument. Instrument means it is a device which measures some physical parameter, process it and give some output, which may be seen by the observer, which may not be seen by the observer, but the output could be used to initiate or to control some process or some parameters. So now let's come. So what is the necessity of the measurement? So you may ask, okay, we will read the measurement system for the whole semester, but what is the necessity of it? Is there any necessity of measurement? So you see, every application of measurements, including those which even not invented, can be said that the necessity of that is kind of three points. It's a 3 bullet points. First is monitoring the process and operation. One thing is that you want to know the what are the parameters are, what are the different physical parameters at some point of time, and that enrich your knowledge, and that you can monitor the process, although you may not take any action based on the measured values. For example, I give some example. Suppose you are observing, you are in some observatory, okay? So you are observing that how the stars are moving, you are observing that how the stars are going further away, what is the velocity, what is the acceleration that universe is expanding. So in that case, it's only the monitoring the process. You don't have anything in your hand to control. Even if you want to control something, you cannot do it. So it is completely monitoring the process and operation. So it is no action you cannot take, just to enrich your knowledge or be aware of the environment and monitor the process and the operation. The next thing, so this part in the monitoring the process and operation is important, but it is less important as for the engineers, because we are not controlling anything based on the measurement. Now the second part is control of process and operation. This is very important. One by one I am coming. So now let's see the monitoring of process and operation. What is that? So certain application of measurement and instrument may be characterized for monitoring some function. Okay. So this is a very extreme example I gave, that universe is expanding, or black hole is but this fluids is coming to black hole, or the radius of the sun, all those, how it is radiating, all those things. Apart from that, small thing like the temperature of the environment, we keep on doing observing temperature of the environment or temperature of the room. Okay, we keep on observing the barometric pressure. Okay, and those are for the observation and monitoring purpose, and there is no control or action is taken based on that. So this is one aspect. The next and biggest or the beautiful or important aspect is the control of process and operation. Okay, so I may think that, okay, I am getting the information, I am monitoring, I am happy. But no, for that may be good for science. But for engineer, we need to twist the environment. We need to twist a system so that we can achieve our desired condition, right? For example, we can control a process and operation. Let's take some example. We'll read this whatever is written later. Let's take some example. Suppose you are running a car, or simply you are running a bike. You have a speedometer on your dashboard, and then you are running it, you are observing what speed it is. Now you feel that the road is narrow, and it is the your bike is moving in the high speed, which is difficult to control. So you slow down the bike, or you see that there is a sign that don't cross 20 km/h limit, so you slow down the bike. Or whenever you see the road is quite empty and it is safe to go ahead with the high speed, you what you do, you generally speed up the bike. So based on the speedometer, you can take the action of the control. So it is the control action what you are taking based on the speedometer. Now, so this process is called the feedback control. You are getting feedback from the instrument, and based on that you are controlling. Take another example. Suppose you have a rooftop tank where you store the water, and then there is a pump, and whenever your water is empty, you pump the water to the rooftop tank and it gets filled. So there are two ways. One is just manual operation. We wait whenever the water is overflow, we switch up the pump, and there might be some automatic control. For example, your pump will be switched off automatically when the water is reached on the highest level. So you have a level measurement device there, and when you get the signal that the level is reached, your water is switched off automatically. Water pump is switched off automatically. Now, if you see that when the level is not reached or it is below some level, your pump is switched on automatically. So it is automatic control. And how the control action is taken based on the measurement on your tank. That means level measurement. So you measure the level, and based on that you take the operation, or you take the action. So this is called the feedback control. And the most beautiful things of any measurement system is to initiate the feedback control. So whenever you go to a engineering application, the main aspect what we think about is the automation. Now you see that from the 90s, this automation is the big thing. So you have to automate everything so that the human intervention is minimum and the accuracy is maximum. So to do the automation, you need to know the status of the parameters which you want to control automatically. For that, you need to measure those parameters using sensors or using measurement system or instrument. And that values can be compared with the set point, and based on that, you can initiate the control action so that the control action happens and then your set point is reached and you can control the parameters what you want to. So if you see the control and instrumentation, those are hand by hand, both the subjects, where control is the action, control dictates what action you should take or your system should take or your instrument should take. And the instrumentation or measurement system gives what is the present value. And based on that, you take the control action. So in this semester, fortunately, you will read both the subject, control system and instrumentation, and both are very important subject. And combining these two in industry, you can achieve the automation. Okay, so now you see the next point you read. Sensors are used to feedback control and many measurement systems themselves used to feedback principles so that the parameters can be controlled. Sensors are used in feedback system and feedback systems are used in sensors. That is very obvious. Okay. So now you see that the instrument or the measurement system can serve as a component in a control system. So what is the component? It is the feedback component through which you can get the feedback of any parameters. You can measure it and feedback it to the set point. So what happens? So based on the measurement system, uh, you get the feedback. That means what is the present value of the parameter, and you have some set point what you want to be, want to get, and you subtract these two. Based on the subtracted value, you operate. You give the signal high or low to the system so that the system happens. Like example, I give that the level control, like the example I give for the but level control is the on-off control. There are some others. Now you come. So when I say that a single control system may require information from measuring instrument, that instrument is a feedback instrument. For example, the industrial machine process control. And now if I take another example, say aircraft. Suppose aircraft you want to control the attitude. That means your angles, orientation. So now for that, what are the sensors you have? You have the gyroscope, and the gyroscope give you the body rate. So the way the body is moving. Suppose your aircraft is starting to roll, so your gyroscope will sense it and give it the body rate. Roll body rate is something, and it is the roll body rate should be 0. And if it is not 0, the subtraction will happen, and then you will get the subtracted value. It will go to the controller will give some signal to the actuators, and actuator will move the control surface of the aircraft, that means the wing and the rudder, so that the aircraft, the opposite action is taken and opposite side motion is given torque so that the roll motion is restored. This is one example. Okay, so this is the biggest example. This is the biggest issues or biggest advantage of control system, and this control system is performed based on the measurements which is done by the instruments. So in this semester and in this subject, we will read about the measuring parameters, how you can. Okay, so now tell me if you have any query up to this. So let me go there. So if anybody has written anything over chat, no. Okay, so you can ask if you have any query. Okay, there is no query. So then let me speak. So whenever you see that, so what I said, that what is the utility of the measurement system? First is monitoring, and I said that is not very much important to an engineer. And next is the control action, which is very important. What I said to summarize, that based on the instrument, measuring instrument, we get to know what is the value of the parameters, and we have what is the value of the desired values, and based on these two we subtract, and when we subtract we get some values, and that values go to the controller, and that controller take the control action so that we get the desired value of the parameter. So this is the case. So So to do a control action, we need to measure the present values, and which is done by using the instrument, which is so in summary, in a single line, that instrumentation of measurement system is essential to take the control action, and which is at most important to automate any process, any engineering process. Okay, so that is the utility. Now tell me, if you have any query, you can write it, you can ask it, there is no issue. So okay, so now let's go more detail into the feedback control. Here there are few blocks that I tried to draw, and actually this figure is taken from the Doebling. So if you see a block, it is a process. If you see another block, it's a measuring instrument, and if you see a block, it's a controller, and if you see a block, it's a fine control element, and so this is control variable. And disturbance, for the time being, let's ignore the disturbance. There is no disturbance. Suppose we have a process. What is process? Now let's take one example of this water tank, what I said. So here, what is the process? The process is the water tank and its water. It's a complete process. Now what is the measuring uh, parameters? We measure the level. So what is the measuring instrument? It is the level sensor. Okay, and these measuring instruments send the values to the controller. Controller has some algorithm inside it, highest level, lowest level. When it goes up, it will switch off and switch on. So, and there is a desired values of the control variable. That means labels should be maintained within this limit to this limit. And controller take both the values. That means that the input from the measurement system and the set point, that means desired values of the control variable, what we call the set point, and based on that it takes the decision. Okay, so in tank control, in this case it's on or off. So if the controller sees that the level is inside the desired values between the highest level and lowest level, and it says that controller take the action that switch off the motor. So motor is switched off. Now let us think that the household people use the water and the level coming down, and it goes beyond the lowest level. So then the feedback system sends that level and send the value to the controller. That level is the beyond the lowest level. Then controller compare it with the set point that the level should be within these two values, and it says that it sees that level is not inside the values, so control action need to be taken. Then controller gives the output that switch on the motor. So this is a kind of, generally controller is built inside a microcontroller or inside a computer. So its value is very less with the voltage. If you think it's kind of 0 to 5 volt, so it gives the 0 to 5 volt. But 0 to 5 volt cannot open or cannot switch on a motor. So what it goes to a relay. Based on that small voltage value, 5 volt, the relay is on. If the relay is on, this it it creates the circuit, and the main line 220 volt goes to the motor, and then motor keeps on running, right? So when motor keeps on running, then the water goes up, and then continuously this measuring instrument keep on sensing the values. And when it goes beyond some level, then controller sees that the water reaches this level, and then controller output becomes zero, and then this zero voltage will go to the relay will switch off, and then immediately the pump will be switched off, and no water will be pumped, and hence the water remain inside the tank. And then this type of things keep on happening. So this is the complete thing. It is a on off control, quite easy thing to see. And we'll come to more complicated examples. Now tell me if you have any query up to this. Disturbance, I am coming. Now you tell me if you have any query up to this. Anybody has anything to say or ask? Nobody is asking anything. No query, no chat box. Okay, fine. So now let's think about more complicated examples. Whatever I was telling, take another example, kind of that uh, roll control, so anti-roll motion. So when there is a aviation civil aircraft, that the roll motion means when the aircraft roll on its axis. The roll motion is quite undesirable because it is very squarey if the aircraft rolls, and it will be very difficult. But sometimes in military application, roll motion is required to avoid the um, a heat from the missile or something. But don't, for the timing, we are not taking that. We are considering we are in a civil aircraft and where the roll motion is unwanted. So we need to control the roll motion. So we need to have a controller in such a way that there is no roll motion. That means the aircraft does not roll. So for that, what we do, we need to know what is the roll angle. So for that, we generally in aircraft, there are three gyroscopes. Gyroscope sense the body rate. I'll tell what is the body rate. There are three gyroscopes. One is on x-axis, another is on y-axis, another is on z-axis mounted. So generally three axis we call. One is roll axis, another is pitch axis, another is yaw axis. So three gyroscopes are mounted on that. So for the time being, let's don't think about yaw motion or pitch motion. We can consider it later because also we need to yaw. Yaw means turning left and right. Pitch means going up and nose down. Roll means moving on its own axis. So let's consider the roll motion for the time being. So there is a gyroscope in the roll axis. So whenever it started rolling, that means it started moving on its own axis. It started moving on its own axis. What happened? Then the gyroscope sends the rate of movement. That means what is the body rate of the movement? What is the body rate of the movement? And based on that, so there is a chat box. There is a question from Utkarsh, difference between relay and transducer. I am coming. Okay, just wait. I am coming to it. Just 1 minute. Okay, so let's discuss that. So whenever you have a roll motion, so there is a gyroscope which sense that the body is tried to rolling. So it sense that the body rate, and based on that, it send the. And if you integrate the body rate, you will get the actual angle. What is the roll angle? So whenever you have a body rate, and what happens? This body rate you send it to the controller, and controller sense that the roll action has started, and then it can measure the angle also. But the desired value is 0. There should not be any angle deflection, and that angle is sent to your set point, subtracted with the set point. And when there is a set point, subtraction happens. It sees that there is some angle, and based on that, controller takes the action and it gives the signal. This signal goes to actuator. And then what actuator does, you have a moving surface on the wing. The actuator press that subsurface up, top or bottom, so that it generates a torque opposite to the roll, and this roll action is nullified. So this is the way. Now there are the few things. Uh, that the student asked that what is the difference between relay, transducer. So I am adding one question in it. What is the difference between relay, difference between transducer, and difference between the actuator? So there are few things. So now let's discuss it. So what is the difference between relay and the transducer? Okay, fine. So actually there is no similarity between relay and transducer. Both two things are different. I'll discuss it, what it is. So if you see that what is the relay, now suppose you have a motor or something that need to switch on or switch off based on the signal which is coming out of computer or very small signal. Now suppose the computer can generate a signal 0 to 5 volt, but with the 5 volt you cannot switch on the motor, right? So for motor you need a line volt. So what you can do, that 5 volt you can generate a magnetic field and which can attract a strip and which can make as a switch. So when you give the 5 volt to the relay, it can attract a magnetic strip and it can act as a switch. So that means 5 volt, when you give, the relay acts as a on switch. So it switch on. So the total 220 volt supply goes to the motor. So that is the function of relay. Based on that small voltage, it switch ons or it provides the main supply or it does not provide the main supply. When the voltage is 0, this magnetization does not happen. That strip or that plate goes out and then switch is break. So it is you can say that it is a circuit breaker or circuit maker. Okay. So that is the relay. Based on the small voltage coming out from the computer, you can make the circuit or switch on the circuit, or you can provide the full 220 volt to the circuit, or based on that, the small voltage from the computer, you can switch off or you can break the circuit. This is called the relay. Okay. And what is transducer? That is completely different. Transducer is the measurement system. Before the getting the, it is a part of the measurement system. When you give some physical parameter, generally that values of the physical parameter or that physical parameters provides, based on that values of the physical parameters, some voltage is generated. Suppose you have a temperature, you give some instrument which provides a voltage based on the temperature. Now you think about with RTD or something. When the temperature is on, more voltage will be more, it is less, voltage will be less. So it transforms a physical parameter to electric parameter. That is called the transducer. Okay. Both are different. And now what I'm saying, what is actuator? Actuator means, suppose you have a small, have you seen a Volvo bus? There is some rod which pushes the door, switch door, close and open, right? So that is kind of actuator, that you give some signal or some voltage and which creates a motion. Motion, either it is a translational motion or a rotational motion. That is called the actuator. Now suppose you have a control voltage, right? So based on the control voltage, you need to go flap up or flap down of an aircraft. How you will do it? The voltage, you have to give some instrument, and if the voltage is more, that instrument rod will come out more and flap will go up more, and the voltage is less, the rod will come less and flap will come down more. So that is the thing. So this is called this is called the actuator. That means it actuates. And what about this movable wing? That is the movable part of the wing. That is called the final control element. Okay. So the actuator acts on the final control element to provide the control action. In our valve case, the actuator may be a push or pull which is attached with the valve, and when you give the voltage, the actuator may pull the valve or push the valve, and the valve becomes the final control element which controls the flow of the water. Okay, so there are the few terms what we are trying to learn, and it is also very important for campus placement or something, because that people who are in industry generally frequently ask this: what is actuator, what is relay, what is transducer, what is final control element. So you try to understand, right? So relay I explained, transducer I explained. What about the final control element? That is actuator. Actuator means whatever the output coming out from the controller, which is very small, which will be relayed, and that will either relate or that can be amplified, and that will go to the some system which will push or pull the final control element to create the motion which will control the process. or some parameters in the process. Okay, so if I take some example, that's what I was taking in the water tank cases. Whenever there is a valve, sometimes your valve need to be fully closed, sometimes it will be fully open, sometimes it will be partially closed when you try to control a flow, not the tank level flow. So for that, your control signal will go to the actuator, and then actuator will create the pull or push motion. That means it's, you can think about an artificial hand which is pulling or pushing the valve, so that valve is closed, semi-closed, or open. That is called the final. That is called the actuator. It's actuate, and the final control element is the valve, which finally control to control the flow. If you take the aircraft system, you see that the actuator is, you can see that below of the wing there are many small box which can pull the flapping, that means wing movable part up and down. So a kind of rod come out and it pushes the movable part to up, or a rod comes in which pull the movable part inside. So that is called the actuator, and the final control element is the movable wing, movable flaps in the wing, and ultimately it controls the anti-roll motion. Okay, that is the full structure. So now you understand what is the final control element, right? And now you understand that what are the controller. Now you understand what is the measuring instrument, and you understand the desired value of the control variable or the set point. Okay, so those are the all the things. So now tell me, you may have some confusion. Definitely you must have. If you don't have, it is very unlikely. So first thing, Utkarsh Pathak, you tell me that you got your answer. Utkarsh, did you get your answer? Okay, fine. So now tell me, all of you, that you understand the final control element, you understand the actuator, you understand the relay, you understand the transducer. All these four things, those are very important. Different blocks in a control loop, which makes a system fully automated. Okay, so I hope all of you understood. Now the last part what I must discuss, that is the disturbance. So till now I did not say anything about the disturbance. What is the meaning? So process means, for in our tank cases it is a level, or how much tank is filled. In our aircraft it's a roll motion, and full aircraft is our process. So process means uh, the system with which we are working, and which is taking some input and giving some output. Now see, whenever we consider some process, till now I said that, that it is absolutely known to us. That means if I give some input, what will be the output, that is known. But now we are not considered, we did not consider till now the disturbance. That means the process, suppose we have an aircraft, we know if we give some input as a control surface, that means the movable surface of the wing and the rudder, we know that how much deflection will happen and how much orientation change will happen. But in this case, we are considering, we are giving input, we know the system, we know the output response. But you consider there are wind gusts, so we are not considering the wind gust. Okay, so that wind gust may be small, maybe less. We are not considering that. So this is the disturbance. So whenever we don't consider anything, we say that we gave some input, we must get some output. But the process is also absolutely known, but the process may not be absolutely known because of several other parameters which we did not consider. For example, the wind gust in the aircraft motion. So this is disturbance. So in process, generally disturbance happens, and that is not modeled. Disturbance we don't model, we cannot model. So our controller should be, and based on that, even if you don't give any input, based on the disturbance, your output or control variable value may change. So our controller knows the process transfer function. You will come to know in control system what transfer function means. Our controller does not know the disturbance, but our controller should be robust enough so that it can take care these unknown values of the disturbance. So our controllers must be robust enough so that it can take care the disturbance. What I mean to say, in absence of disturbance, our controller should work properly. It should control the output variables very nicely. Even with the presence of the disturbance also, it can control the output variable nicely. Suppose when disturbance comes, it may happen that disturbance is not present always. It may happen that suddenly disturbance comes and then there is no disturbance. It may happen that some always disturbance is present in terms of noise or something. So whatever the type of the disturbance may be, the controller should give the control action such a way that output variable is controlled. Okay. So disturbance is not desired, but it is there. So we have to build the controller. So it's a challenge of the controller, and measuring instrument always measure the output parameters. There is no point of it. Whether it is disturbance is there or not, it changes the output parameters and measuring, keep on measuring those values. So this is the case. Now tell me if you have any doubt in this. So the full control loop, I explained what will be the full control loop and how it will look like, what is the meaning of disturbance, what is the meaning of process, what is the meaning of measurement, what is the meaning of controller, what is the meaning of actuator, what is the meaning of final control element, what is the meaning of relay, what is the meaning of transducer. So everything I discussed. So this is a full loop in any automated system, and all the parameters you will see in the industry when you are considering some process to design, you have to design all the things. So this is the full structure. And where we'll now, which topic we learn in depth? We learn in depth the feedback control, that feedback control element. That means the instrument which measure the parameters and which is feedback to the control system. So those instruments will keep on learning in detail. That means this measuring instrument, this part will be our syllabus. In 3350 is the control system. This part will be the syllabus, this part and process. Okay. So whenever you learn all the box, you know the full automatic control or the automation you can achieve. So this is the part. So now tell me if you have any query up to this point. No query? Okay, then if you have no query, then we can end here. The new topic or the another section will start on the tomorrow. If you have any query till now, you can write it, you can ask it. There is no question. This is the main basic things. Now we will gradually enter into the measurement system, but this is the main basic block of the automation, and you should know it to overall conceptualize the system and how it automates. Okay. Is it fine? Okay. So then today we end here. Tomorrow we have class from 11 to 12, I guess. 11 to 12. And we'll meet tomorrow again. So thank you for being in the class. And you try to write in the notebook. Recording you are taking, it is fine. But my experience is you take records and the end of the semester, it's the 45 hours of record, and it's very painful to hear and understand. It is better to quickly take a note very frequently, and then that note will be useful when you go for the class exam. Okay, now there is a question, sir, final control element and the actuator difference is confusing. It's not confusing. You try to understand two things. One is the solenoid, which is acting, and another is the valve. Solenoid means you can consider that artificial hand which can push the valve in or out, and valve is an element which will control the flow. Okay, so here the artificial hand, which is solenoid, which is doing pulling and pushing of the valve, that is called the actuator, and the valve which is controlling the final flow of the fluid in the process is the final control element. That means, and if you see the flapping wings, moving part of the wings, you have small rods attached with that. When you push the rod, what will happen? That flapping, that wing, movable part of the wing will go up or down so that the flight is controlled. So whenever the rod which is pushing in or out, that is the actuator. and the final flap which is going up and down, that is the final control element. Then it is not confusing. So the actuators create a motion so that the movement of final control element happens, so that the process is controlled. Is it fine? Do you understand? Ganapati, do you understand? Yes, fine. Okay, so you keep on asking question. You can raise your voice, not only writing on chat. It's perfectly fine. If you don't understand, your concept will not be clear, and your question will be clear the concept to other student also. So keep on asking. Okay. So today, so let's end here. Tomorrow we'll come again to class, and next week I'll discuss with you about your free time and all, so that we can club 2 classes together and we can move further. Okay. Thank you, all of you. So let's drop now.